What's going on? Today, we're going to be talking about an alternative energy source called cold fusion. You might ask, well, what is cold fusion and how does it work exactly? Cold fusion is essentially a theoretical nuclear reaction at or near room temperature to produce heat, which we can then turn into energy. It basically works by applying a voltage through two electrodes that are in a solution of heavy water and lithium salts. This runs a current between a strip of palladium to platinum coils. In the solution, the D2O molecules split to form a negative DO molecule and a positive D molecule. The negative DO molecule is attracted then to the positively charged coil. Once there, two of the negative DO molecules join to create a D2O molecule, releasing an extra oxygen atom to the surface. The positive D molecule that split off earlier is attracted to the negatively charged palladium strip, where it works into the strip. As more and more deuterium fill the palladium, it becomes saturated. As more and more deuterium is pumped into the mix, the deuterium then groups up into two, creating helium-4 isotope. This fusion creates a lot of heat. This creates an estimated 24 million electron volts for every helium-4 isotope created. This whole theory is cool and all, but it has not been proven to be possible yet. The reason we haven't been able to accomplish this cold fusion theory yet is because it's so far been pretty much impossible. Scientists have been trying to figure out cold fusion for decades, but no one has yielded legit answers. Whenever someone would think they figured out cold fusion and got it to work, there was no gamma detected, meaning that fusion did not occur. That, or they just couldn't prove it after they proved it the first time. The main issue that people had is that when trying to put the two deuterium atoms together, the electrons were so far outside the nucleus that it makes it really hard to fuse them together because the electrons want to push away from each other. There's this thing called a muse, and it is basically a heavier electron that orbits closer to the nucleus, making it easier to be able to fuse the deuterium atoms together. The only issue with that is it takes more energy to create a muse than we would actually get from the fusion, making it pretty much useless. Is it easy to produce? If cold fusion were indeed possible and reliable, it would be pretty easy to produce as it doesn't take many resources and work to produce a lot of energy because the molecules do most of the work themselves. All we really would need to do is turn the heat into electricity and transport it to people. But since cold fusion isn't really possible yet, no, it's absolutely not easy to produce. But theoretically, if cold fusion were to work, we would be able to produce sustainable power for pretty much the entire world. One lightning bolt generates about 300 million volts, and one lightning bolt can also power a 100-watt incandescent light bulb for 3 months. And one fusion of a couple deuterium atoms would be nearly a 12th of the power of a lightning strike. One fusion of two deuteriums. Just to put that into perspective for you for how much energy that really is. That's absolutely insane. Now let's talk some cash money. How much is this thing gonna cost us? Well, originally the US Department of Energy estimated that funding of $22 billion would be substantial enough to figure out the solution to cold fusion. But now they've upped the price and are calling for a $68 billion operation. Now, as a citizen, other than taxes paid for developing this source of energy, we would pay an estimated $25 per megawatt hour, compared to what we have right now in Michigan at $70 per megawatt hour on average. So that's a pretty crazy difference. And this would obviously make a huge effect on the economy, as people will have more money to spend But people will also lose money in the gas and oil industry as less and less people will rely on their products, possibly killing jobs. But then on the flip side, there will be more jobs in the field of cold fusion. Costs of machines such as generators could quite possibly fall drastically, by a factor of 200 even, as less and less people will rely on gas-powered generators and other gas-powered tools. Well, I hope I was able to shed some light to the subject of cold fusion for you and help you learn a little bit more about what it is, how it works, and what it'll do for us.